Classification of real numbers, part 3. In the first video, I've defined everything. In the second video, I worked a type of example that you'll see on your homework. And in this example, I'm going to work 2 more examples of which you will see on your homework. But before we work through either of these 2 examples here, I need to define some notation for you. Remember that word notation means the way we notate or write things, and so I need to give you some definitions for each of these notations here. The first one is this weird looking capital E guy. What that means is, the official definition is an element in. Now, when I read a statement with this E thing in it, I really just think of the word in. Is that number in that group or in that box that we looked at earlier? The other symbol we have here is a squished looking C. That means, is it a subset of? Now the word subset, that means, is it a smaller group within a larger group? So the example that I typically give for this is if I had a large group of fruit, I could come up with subsets of that, of apples and pears and bananas. So apples are a subset of fruit, and pears are a subset of fruit. And I could even define smaller subsets of that, but hopefully that proves my point, what a subset is. So, example 1, part A asks if pi is in the Z group. And this is why I gave you those symbols earlier, so when you saw problems like this, you know what it's talking about. The first thing that you probably should do is look up what is the Z group and what exactly fits into that group. The Z group is integers, and the integers are all positive and all negative whole numbers. So now your question is pi in the positive and negative whole number group? And the answer is no. Pi is not a positive or negative whole number, so this is a no statement. And so the answer to this one is false. And so I should have explained to you earlier that these are all true-false questions, and the answer to A is false. So hopefully now that you've seen me work through one example of these, I encourage you to pause the video and see if you can finish all of the examples in both example 1 and example 2. Okay, in part B, if we look at the double bar Q, Q stands for rational. And remember the prefix of that is ratio, which stands for fractions, or anything that can be written as fractions. So, fractions, whole numbers, decimals that stop, and decimals that repeat. So, is pi in that group? And the answer is no, meaning the overall answer to this statement is false, because pi is a decimal that does not stop and does not repeat. Example C, the H group. H was a symbol for irrational numbers. And we could define this one of 2 ways. A number that's not rational, or a number that has a decimal that doesn't stop and doesn't repeat. And that's the perfect example for pi. So the answer to this statement is a true statement. Pi is a crazy ugly decimal. It doesn't stop and it doesn't repeat, so it fits into the irrational or the H group. Last but not least, my double bar R, that stands for real number or any number that can be put on the number line. And pi is 3.14, so on and so forth. So pi is a real number. So the answer to this is true. Remember, all of the numbers that we see so far will always be real numbers. Okay, example 2. Is W a subset of Z, and B is Z a subset of W? So remember, back to my fruit example, apples are a subset of fruit. So the subset means a smaller group within a group. So basically, the answer to A or B, only one of them can be true unless the groups are exactly the same, which is not the case. So I need to figure out how my boxes work. If I look back to my chart that I gave you earlier, I had a big box which stands for Z, or all positive and negative whole numbers, or integers. And then we split that into two smaller boxes, one where I take off the negative numbers and one where I just look at the whole number part of it, the double bar W, which stands for 0, 1, 2, 3, so on and so forth. So in this case, a whole number is a subset of an integer. So W is a subset of Z. So that means this one is true, and that means this other one here is false. It cannot work the other way around. So I have my answers for both of those examples here. Moving on to my last example here, of which you might see on the homework. Again, I've given you another list of numbers. Notice it has the braces around it. Remember, these braces represent a set. So this is a set of numbers. And we need to figure out which numbers from this list fits into each of these categories down here. I'll work the first one for you so you can see how it works. And after that, I'll suggest that you work the other ones on your own. So example A asks for N, which stands for the natural numbers. Remember that these are the numbers that are most natural to us, the counting numbers. So I'm going to look through this list here, and I'm going to see if I can find any counting numbers, meaning any positive whole numbers which don't include 0. So root 5, not a whole number. 0.3 is not a whole number, not a whole number. This is a whole number, but it's negative, so that doesn't fit in there. 11 over 4 is not a whole number. 6 is my only whole number that fits into this, and then pi over 6. So my only natural number from this list is 6, so that's my final answer there. So now I suggest you pause the video and see if you can work the rest of these on your own. So Z. Z stands for integers. And integers are all positive and negative whole numbers. So we're looking for all whole numbers here, both positive and negative. So the answers to that are negative 12 and positive 6. Starting over in part C, I'm looking for Q, which stands for rational numbers. Remember, the prefix is ratio, and ratio stands for fractions. So anything that can be written as a fraction. Fractions, whole numbers, decimals that stop, decimals that repeat. Square root of 5 can be simplified as a decimal, but none that stops or repeats. 0.3 is a repeating decimal. Negative 0.48 is a terminating decimal. Negative 12 is a whole number. 11 over 4 is a fraction. 6 is a whole number. And pi over 6 is a fraction. But remember, half of it is irrational, which makes the whole thing irrational. Moving on to example D, H stands for the irrational numbers. And remember, there's two ways to kind of think about this. Those numbers that aren't rational, or those numbers that aren't in part C, or those numbers that don't stop and don't repeat. And remember, most of these come from square roots that don't simplify evenly. The way I'm going to work this problem is I'm just going to use all of the ones that I didn't use in part C, but double checking that they fit into the definition. Decimals that don't stop and decimals that don't repeat. So, square root of 5 didn't simplify, so that fits into there. And pi over 6. Half of it is irrational, so that makes the whole thing irrational. Last, part E is my double bar R, or things for real numbers. And every number is a real number at this point, so every number on this list. Square root of 5, 0.3 repeating, negative 0.48, negative 12, 11 over 4, 6, and pi over 6. All numbers that can be represented on the number line are classified as real numbers. Now that is my last homework example that I have, and so that's where this video will end.